So for activity 3.2, we're given the graph of the second derivative, and we're asked to find all the inflection points and describe all the concavity in A and B. And I'm going to do those actually together because I think it's easiest to make the number line first and then go from there. So it's going to be very similar to what we did on the first derivative test. Now our second derivative is 0 at -1 and at 2. Now we don't need to do test points because we can clearly see the graph goes plus, minus, minus. Now for our original graph, that means concave up, concave down, concave down. So we do have one inflection point. So one inflection point at x equals -1. B, we're going to describe the concavity. So we see that it's concave up wherever it's positive, so -infinity to -1, and concave down from -1 to -2 and -2 to infinity. The reason we exclude -2 is because it was a place where our second derivative was 0, so it's a place where the rate of change is not changing. Okay. C. Suppose that we're given that g prime of -1.67857 equals 0, and we want to identify if it's a min or a max. Well, plug it in. Notice for -1.657, our graph is concave up, so that means it would sit at the bottom of our u, so it would be a local min by our second derivative test. Finally, D, if we had to determine what the degree of g would be, well, notice with what we see of g double prime, we have a third degree polynomial. Okay, we have two turning points. The degree is at least one more. Or we could look at the zeros. We have 1 0 here and a even repeated 0 here. So this is at least a degree 3. That means g prime would be at least a degree 4, which means g would be at least a degree 5.